So I'm from a little team called BuddyCloud. We're an open source project, and we have the big, hairy, audacious goal to kind of reinvent messaging. We've looked at email, and we've said, like, this is this protocol that's been around for the last 30 years. Let's think about what do we do for the next 30 years. So we think that we can really build something better. Right now we're working with governments, with small companies, and lots of other small software teams to kind of change messaging, to let you share files better, to shift messages around. And this shifting messages around is really important. If you think about the internet, it's totally built on these little boxes of a Facebook feed or a Twitter feed or this crappy forum software feed, where you type stuff in and it gets pushed out to your followers, you get retweets back, or you get likes back, or you get flame wars back from the crappy forum software. And we think this can be done a lot better, but there's still a lot of incompatibility out there. So I got a call from another South African here, and he was like a little bit desperate. He'd arrived with his South African plug saying, like, hey man, do you have a power adapter? I have nothing, I can't find anybody in the hotel, what do we do? And this really reminds me a lot of like how we build our software right now. We build software much like a plug, it plugs in and it works perfectly with an API. But as soon as there's some other system that comes along, we try to like jimmy it with a power adapter, those ones you stick in the wall, you hope they don't fall out, and it sort of hopefully converts to the right voltage and whatnot. And that's kind of the world we're living in right now. It's kind of sucky. So we think we can do this a little bit better. And just so we're clear about this, when I'm talking about APIs, I'm talking about like systems that interconnect with other systems. Very simple. When I'm talking about protocols, I'm really talking about like a gentleman's agreement. Like how does, when we're driving down the road, I'm pretty much on the right-hand side, you pass me on the left, and that kind of works as long as we all follow the rules. But why does this matter? Like, why should we really care about this? Well, back in the olden days, once upon a time, we used to build these nice distributed systems, and if you scratch underneath the surface of the internet, you still find a few of them around, and they've been around for a hell of a long time. For example, DNS. This is something that was built in the 80s, and yet it's so critical to what we're doing. And then we've thrown a lot of that away. We're in this world where we're being told like how we can and can't build against other people's APIs, and what we can do. And this kind of reminds me of the old days where we had the mainframe, and you had to connect in, and those of us remember, like, you'd have all your data on a centralized system, and you were totally beholden to somebody else on how you would interact with this stuff. And then along came the PC, and suddenly everybody could do everything, and there was this huge like wave of innovation that happened in the bedroom, in the home, in the office, everywhere. And we've kind of lost that. We've lost a lot of that. And what I want to talk to you about today is how do we get some of that back? How do we go back to the future and start building and designing these distributed systems? And for that, we need protocols, because protocols let us agree on a sort of common way on how we can interact. And the other super cool thing about this is when we can push this sort of innovation out. So instead of being on a centralized like team in the middle controlling what we can and can't do, when we can all work on the edge of the system, then the amount of innovation really explodes, like the PC exploded. So Robert Scoble has this interesting analogy. It's called the ice cream of the internet, and we have this like super cool stuff, like things happening right now. We have a phone in our pockets where we can like pull it out, and we've got the entire world's information at our fingertips. We can take photos, and they magically appear on certain websites, or you can swipe up, and Google Now tells you where to go. And we're living in this like super cool world of really cool stuff happening. But we're not really asking ourselves, like, do we want to be sharing all of this information publicly? Now, I don't want to stand up in front of you and say, look, centralized is bad, decentralized is good. I think the answer to that is far more nuanced. The Yogi Berra says, when you come to the fork in the road, you take it. Centralized definitely has its advantages. Like if you think about Facebook, they came along, and if they'd had to sit there and design a distributed system, distributed is really hard. Like when you don't control all the nodes on the network, it's a tough problem to solve. Like nodes go down, how do you resynchronize messages, things like that. So, but we also know that decentralized kind of wins in the long term. Like the car, decentralized model. The GSM protocol, it's decentralized. PC again. Email. So we did solve this with email. Email is in many ways a pretty fantastic protocol. It's been around for 30 years. Like there's not many people who can write an app and say, yeah, my app's, okay, maybe PHP, but very few systems that have been around for as long as something like email. And it works well because people can innovate on different areas of the stack. You can innovate on the server, you can innovate on the client. There's a sort of gentleman's agreement on how it should work. This is codified up into protocols and RFCs. But there's also, well, we know it's insecure. Client to server is pretty secure, but server to server, as we're finding out from some of the Snowden stuff, is pretty damn insecure. It's completely clear text. The other thing, if you think about email, it's like it could be so much better. If you get an email message, imagine you're getting an invoice. If this invoice was tagged up and dealt with the right way, it wouldn't land in your inbox. You wouldn't have to process it. It would just magically go to your accounting software or to your accountant. I mean, seriously, this is a bit broken. And let me just share one other piece of brokenness, and then we'll think about how do we fix this. So the other part is like, we have all of these services. These are great services. They let us do super awesome things. But why do we have to have 3 different accounts on these systems to be able to post and go to these different sites to post, and we never have these comments coming back? I mean, we're pretty smart people. I'm sure we all agree that this stuff could be a little bit better. So let's think about how do we build this better. And I'm going to share with you some of the things that myself and my team have been thinking about, some of the problems that we faced and how we've come up with them. We know that the system has to have structured messages. You know, if you're passing messages around between systems, you kind of want it to be tagged up in the right way. So there's like the activity feed format. That's subject, object, verb. So so-and-so tagged so-and-so in so-and-so's photo. So that's a good starting point, and that's sort of some of the stuff that we're starting to think about. We definitely want it distributed. Anybody should be able to host it. It should be reliable, and it should be easy to implement. So in terms of thinking, like, how do we use protocols to design a system where anybody can run it, and anybody can build apps on it, and all of these different apps and systems will intercommunicate? The first thing we need to think about is how do we deal with addressing? Like, you know, there've been some social networks that have said your identity on this network is like a URL. That sort of works okay, but people rarely sort of think about their email address as an identity. So we took the assumption that email is a good starting point for this. It doesn't have to be email, but the format should be somewhat like email. And that works really well because you've kind of got a system, example.com knows how to connect to remote.com. It knows that there's a user at these different services. And then all we have to worry about is how do we build an API, and how do we build this federation protocol between different domains so that these messages can be passed. And then if we're building this, you know, we have to think about how do these servers find each other and interconnect. So again, we're going back to our roots. The 30-year-old technology comes to the rescue. DNS has this great record in it. It's called the SRV record. And what this basically says is, like, when you want to do something on a remote domain, you can find out which server is responsible for that. It's not dissimilar to the MX record in email, which says sending email, connect to the server, that's the email server. This is a more generalized thing. And what this is saying is, like, when you want to talk to your app running on a remote site, basically connect to port 443 and do stuff using the protocol. But then like, we have clients, and going back to our email analogy, you currently, if you have to set up email on your phone, you pull it out, and you've got to find out what your mail server is, where to send email, and stuff like that. You've got to type that all in. We can do much better than that. We can actually have a protocol for discovering like where to connect. And this is important because imagine you build this super awesome next generation communication protocol, and it's an app and you can download it. It's important because the user expects to just log in with their user@domain.com. And you want to be able to find out domain.com, where do I have to go for that? Like, where is the API endpoint for domain.com? And the guys over at IANA have solved this. They've said, look, there's this DNS record that you can use to look up stuff. So users don't have to put in anything more than just their username and password. And this basically is a text record, very easy to parse in any software. And that would basically result in connecting to this server, port 443, and then your API would be prefixed with /API. There's 3 more problems we have to solve before we can come up with our super awesome next generation communication protocol. Is servers not always being online? So how do we resync our servers? This is not something that's that there's a perfect answer to. On the Buddy Cloud side of things, we say that, look, we can't guarantee that all servers would always be online, but when they do come online, they can ping out to all of the other servers with users that follow their channels or their data. And at the same time, remote servers can always keep polling, like, are you back online? Are you back online? But it's just something to be aware of, because if you assume all servers are online, you're going to end up with a lot of problems. And then the time to glass is really important. We've worked kind of with the assumption that within 1 second, you really want to have data appearing on the mobile screen. But again, in a distributed world, you've got to really rethink a lot of these assumptions. So imagine if I turn on my phone and I'm following like 20 people on 15 different domains. My phone now has to go out and discover these, do DNS lookups, set up TLS connections between 15 other different domains. And it's just not really going to be a very impressive time to glass. So this is something that we tried to solve in Buddy Cloud by building this inbox server. So what happens is when your client is not online, these remote servers are pushing data in and pushing updates through into your inbox. It's basically a spool. You come back online, and within 1 second, you've got data appearing on your screen. And I think this is an important sort of architectural or architectural decision for any type of software to be building these things, so that you've got a very, very fast time to glass. And then it's not just jealous lovers that are trying to read our email. This is a really tricky problem to solve. Like, I don't claim that we've solved it well yet. When you have, of course, email hasn't even solved the bottom part of how do we connect servers to servers. This is something that we've solved. But we still have to work with the assumption that you trust your sysadmin. So when you've got code running on a remote server, you have to kind of trust the remote sysadmin as well. The real solution to this is going to be to have systems that do end-to-end cryptography. But my parents are not so good, and I'm not even so good at managing like private keys on my end devices and distributing them to different end devices. It's a really tough problem to solve. It is something that we've built the architecture for, and we're trying to think about how do we solve it, but it's a tough one. So there's a couple of other teams that are also working on this type of stuff. You've probably all heard of the Diaspora project. There's the Freedom Box from the Debian guys. Pump is a pretty cool NPM-based system that Evan's working on. And there's other systems, like the and yet guys are doing some pretty awesome stuff with building lots of small systems that then interconnect. So there is stuff happening in this space. And my call to you is that we you get involved with standards committees. Like when you're building your apps, think about if this is something that can be really like pushed to a broader audience. However, there's a big warning about standards committees. There's two types of people on standards committees. The first one is the type of person who enjoys being on a standards committee and enjoys writing specs. And these are people you really, really want to avoid. Do not go near them. They're toxic. We try to take the other approach. We try to like build software, generalize it, and then come back. And this is so much more powerful because the first group of people really think about how the world should be, and I think it's so much better to accept the world as it is and then build stuff. And we discovered that this the hard way. We sort of designed something. We found we had about 1 million users using this chat application that we built on Nokia phones, and it turned out to be a complete nightmare. There were so many bad actors that we had to actually go back and change the spec and change the protocol to put in some more sensible assumptions about what people would, the initial state of the network. So I can also highly recommend working with the guys at the XMPP Standards Foundation. This is like one of the most friendly standards committees. If you ever need to pass messages between systems, these guys would love to hear from you. It's very easy to write a spec. They'll accept it. They'll probably give a little bit of pushback, but it's a nice group, and they organize awesome summits every year. So I've spoken a little bit about BuddyCloud. We've built most of the system. We think we've solved a lot of these problems. The code is, of course, all open source. We've tried to build reference implementations wherever it's possible. What we want is that people start using the code and building in like generalized communication into their products. Like, I think it's crazy that every single product we rebuild the messaging stack every single time. It's like if we had if we wanted to include maps on a web page, we're not going to build like map tile renderers. We simply drop some code in. But I think that using APIs and protocols, we can actually build a slightly better way of this communication. And this is our roadmap. We're almost ready to do an initial release. Of course, there's stuff working on the web already if you go to buddycloud.com. And my call out is like, this, if we are going to build the next 30 years of messaging, this is the type of audience. Like, if we can't solve this here in this room, then we're stuck with email and Facebook feeds. I think it's time to change that. So let's innovate on the edge and make a difference. Thanks, everyone.